Hello all, welcome back to the tutorial session on the topic performance measure of regression in machine learning algorithm. In this session, we are going to discuss about what is simply Huber laws and quantile laws, mostly used in deep learning algorithms, as in artificial neural network. What is simply Huber laws? It is a combination of MSCE and MEAE. See here, by looking at this formula itself, we can say this square term indicates MSCE and this absolute error difference indicates your mean absolute error. For small errors, it will behave as MSCE, and for huge errors or large errors, it behaves like MEAE. So, what this del indicates? This del indicates is an hyperparameter tuning or uh, threshold value. If the absolute error is less than or equal to a threshold value, you need to use MSCE formulae, namely half of y minus y hat the whole square. If else, what mean? Absolute error is greater than your threshold value, we need to go with del of absolute error of actual value minus predicted value minus 0.5 del. So it takes the best value of, it takes the merits of MSCE and it takes the merits of MEAE alone. So we can see with an example for Huber laws, and here is the condition of our size. So our actual house price is 50 for 500 square feet and predicted value is 52 and the error is minus 2, and if you take the absolute error you will get 2. If you sum all those things it is 15. Fine. Now we can see y minus y hat, whether we need to check. In this case we are going to assume the hyperparameter tuning a threshold value as 1 for our understanding purpose. Now we need to calculate whether this del, as considering it as 1, we need to rearrange this formula. If you calculate this, if you substitute del equal to 1, you will get absolute error of y minus y hat minus 0.5 answer. So it is 0.5 into 1, you will get 0.5. That's what I have written here. Loss equal to y absolute error of y minus y hat minus 0.5. With that as an input, now we need to check whether our absolute error is less than or equal to hyperparameter value. So it is 2. So this 2 is higher than the hyperparameter value. So we need to go with the second equation. So namely, for all the equations 2, 2, 2, 5, 2, 2, all the values are higher than your hyperparameter value or threshold value. So we need to go with the second equation. So first equation we no need to go. So if we go with MEAE in this case, mean absolute error, if you see the loss, how we can calculate the loss? Same way, it's absolute error difference, it is 2. 2 minus 0.5, you are getting 0.5. Again 2 minus 0.5, it's 1.5, and we can proceed with that. And 5 minus 0.5, it is where that 0.5 comes from the equation, it is 4.5. And if you sum all the losses and absolute error, it is 15 and 12. So now we are going to play with only the losses. So Huber loss is nothing but 12 divided by total number of input feature is 6. So 12 divided by 6, it is, you are getting it as 2. So in MSCE, big errors becomes 25. See here, in previous case MSME, for fifth point, error of 5, you are getting square term. So it is 25, right? But in this case, see, it is reduced to 4.5. And Huber loss, it becomes, instead of 25, it becomes 4.5. So Huber loss reduces the impact of outliers. That's the main takeaway. This Huber loss reduces the impact of outliers. Now the second topic, see here, this green curve indicates your Huber loss and this blue color curve indicates your square loss. So in quantile loss, the last topic, the quantile loss evaluates how well prediction matches chosen percentile of the particular data. So normally what the median will do, you have 0 here and it will go till 100, right? If you need to calculate the median, what you will do, you will calculate the percentile of 50. Always it will give the answer of 50. But if you want to check your performance of the model at 20% of quantile means, we can go with this quantile loss formula. That is possible in this quantile loss. Or if I need to calculate in our example, now I am going to calculate for 70% of quantile, right? That which is possible in this case. So quantile loss measures prediction error based on chosen percentile, giving different importance to overestimation and underestimation. In this case, I have given the quantile loss of pro tau of y minus y hat, which is equal to tau of y minus y hat when y minus y hat is greater than or equal to 0. Else, tau minus tau 1 into y minus y hat for other cases. Else by mean y minus y hat is less than 0. For negative values, we need to go with this equation, and for positive values, we need to go with these equations. Let's see, for example, what happens for our example. We have input size of our house and actual price 50 and predicted price as 52, and error as 50 minus 52, you will get minus 2, and we need to go with our actual calculation. This we need to check y minus y hat is less than or equal to 0 or greater than or equal to 0. By looking at this minus 2, it is less than 0. We need to go with the second equation. So what's the actual tau? Tau value in this is 70th percentile we are going to calculate. So tau value is 0.7. So y minus y hat, if it is greater than 0, we need to go with 0.7. Where is this 0.7? This is tau 0.7 of y minus y hat. If it is less than 0, for negative cases, tau value is 0.7 minus 1, that you will get minus 0.3 into y minus y hat. So in first case it is less than, it's a negative, it is less than 0. So we are going with the second equation, that is minus 0.3 into the actual difference between actual value and predicted value is minus 2. So you will get minus 0.3 into minus 2, you will get 0.6. And same way, look at the second value, it is positive. So we are going with the first equation, that is 0.7 into 2, you will get 1.2, 1.4. Same way for third case, 0.7 into 2, you will get 1.4. And for fourth case, it is negative value, it is minus 0.3 into minus 5, you will get 1.5. And this is how you need to calculate the losses. And you need to sum all those losses in order to calculate the quantile loss. So if you sum all those values losses, you will get 7.7. So your quantile will loss divided by 6, your quantile loss will be 1.283. What is that 1.283 indicates? For example, MAE in same problem case study, we have got MAE as 2.5, but for our case, for quantile loss we are considered as 0.7, we are getting MAE quantile loss as 1.283. So it is half the value of MAE. So right, quantile loss is roughly half scale of MAE. You can say it's a good model. So if you see, the difference is very high. For if very large difference from MAE, you can say it is a very bad model. So if you get only 50% of MAE, means you can say the model is good. Health model is the worst model. So for underestimate, by using the formula, if error is greater than 0, penalty is given as 0.7 into error. It is very high, right? And for overestimate, if error is less than 0, the penalty is 0.3 into error. So by the time it is very less. So what's the takeaway or inference from this particular slide? It is more dangerous to predict too low than too high. Example, predicting electricity demand. For tomorrow, we are going to predict the actual demand is 10 kilowatts. You can say 10 megawatts, but your model says as 5 megawatts. You have a huge difference. The 5 megawatt is missing. So right, so it's a very dangerous one. So actual value we need is 10 megawatt, but model says it's 5 megawatt. There is a shortage of 5 megawatt, but reverse process may happen. For example, the actual demand is 5 megawatt, but your model prediction is 10 megawatt, so that we are increasing our demand electricity purpose. We are generating more electricity. By that case, there won't be only some amount of losses will be there, but we are not going to match the actual demand in first case. So it is very unethical way to say that answer. Thank you. In this session, we have discussed about quantile loss and Huber loss. We'll meet you in another video. Thank you.